There is a car factory in rural Georgia where you can have a normal conversation while a car is being assembled 5 feet away from you. No hearing protection, no deafening stamp press noise, no diesel fumes, just clean air, natural light pouring through skylights, and machines doing things that were considered science fiction 10 years ago. What makes that extraordinary is not the silence alone. It is what is producing that silence. Hundreds of robots moving in perfect coordination, guided by a private 5G network, trained inside a digital copy of the building before they ever touch the real floor, watched over by a 4-legged robot conducting quality inspections after every single weld. A humanoid robot, standing upright, walking on 2 legs, sorting parts in the warehouse, receiving software updates that teach it new skills overnight. Not a concept facility, not a pilot plant, fully operational, open to the world in March 2025, sitting on 2,284 acres of what 3 years ago was Georgia farmland, the Hyundai Motor Group Metaplant America, HMGMA, the sheer audacity of what has been built here in 24 months for $7.6 billion may be the most significant thing to happen to American manufacturing since Henry Ford bolted together the first moving assembly line in 1913. Ford's moving conveyor belt stood for 111 years as the backbone of every car factory on Earth. At HMGMA, they abandoned it. What replaced it rewrites the rules. To understand why this factory is different from anything that came before it, you have to start not with the building, but with the land. Bryan County, Georgia. Population roughly 40,000. About 30 miles west of Savannah, which means access to one of the busiest ports on the East Coast, a direct rail corridor, and a workforce that by October 2022 had never assembled an automobile in its life. Groundbreaking was October 26, 2022. 24 months later, the first Hyundai Ioniq 5 rolled off the production line. For context, Amazon's largest fulfillment warehouses, buildings with a fraction of the mechanical complexity of an auto plant, typically take 18 to 24 months to build. HMGMA, at over 16 million square feet of factory floor, equivalent to roughly 275 American football fields laid side by side, went from dirt to a fully operational vehicle plant in the same window. No major auto manufacturer had pulled that off in the modern era. Not in the United States. Not anywhere. The total investment, once you factor in the battery production joint ventures on the same campus, reaches $12.6 billion. That makes HMGMA the single largest economic investment in the history of the state of Georgia. The plant alone accounts for $7.59 billion. At full ramp, it will produce 500,000 vehicles per year. As of 2026, it is running at roughly 300,000. The workforce currently stands at 3,200 employees. Hyundai calls them Meta Pros, with a target of 8,500 by 2031. Surrounding the plant, 17 direct suppliers have co-located on and around the campus, representing a combined $2.7 billion in additional investment and approximately 7,000 more jobs. Hyundai Steel, Hyundai Mobis, Hyundai Transys, a full ecosystem, purpose-built around a single facility. Now, let's go inside. Every car built at HMGMA begins the same way every car built anywhere in the world begins, with steel. Enormous coils of sheet steel, each one weighing several tons, are fed into the stamping shop, the first major stage of production. Giant press machines, each one exerting thousands of tons of pressure, punch, cut, and form flat metal into 3-dimensional panels, the hood of an Ioniq 5, the door skin, the roof, the quarter panel. Each piece stamped from a single sheet with tolerances measured in fractions of a millimeter. At most stamping facilities, the noise is staggering. The floor vibrates. You feel it in your chest before you hear it with your ears. At HMGMA, that has been engineered away. The press area is acoustically isolated. Sound is actively channeled underground through the building's foundation design, dissipated before it can reach the floor where people work. Walk into the stamping area at HMGMA without earplugs, and you walk out with your hearing perfectly intact. That is not a marketing claim. Engineers from competing manufacturers have visited this facility and come back describing it the same way. Quiet, in a way that has no business existing in a factory that size. From stamping, the panels travel to the body shop. Here is where HMGMA separates itself from every other vehicle manufacturing facility on Earth. Not in increments, but in a different category entirely. The body shop is 100% automated. Every single weld in that room is performed by a robot. Not mostly, not approximately, 100%. At a traditional auto plant, certain welds still require a human hand, tight angles, difficult geometry, spots a robot arm cannot reach without repositioning 3 times and slowing the line. At HMGMA, those problems were solved at the design stage. The facility was engineered specifically to achieve full automation in the body shop, and it achieved it. Body panel production across the facility runs at 91% automation, one of the highest figures ever recorded at an operational vehicle plant. But one specific system in the body shop has attracted the attention of every engineer who has seen it operate: the world's first autonomous door gap correction system. Here is why that matters. The gap between a car door and the body of the car, that thin, even channel running around the entire perimeter of the door, has to be consistent to within less than a millimeter on every vehicle, every time. Too wide in one spot, the door whistles at speed. Too tight in another, it binds on cold mornings when the metal contracts. Getting that gap perfect has historically required human eyes and human hands. Skilled technicians with gauges, with years of feel built into their fingers. It is one of the reasons fit and finish has always been a measure of build quality that separates premium vehicles from budget ones. At HMGMA, that job no longer belongs to a human being. The autonomous door gap correction system scans each body in the shop, identifies deviations in real time, and physically corrects the door positioning before the vehicle moves to the next station. Zero gaps out of tolerance. Not statistically close to zero. Zero. Guaranteed. Hyundai has never deployed it at any other facility in the world. HMGMA is where it ran for the first time. Now here is where the body shop gets stranger. After each welding cycle, before the car body moves on, a four-legged robot walks out onto the floor and conducts a full exterior inspection. Boston Dynamics Spot. You have likely seen it before. The quadruped robot that walks like a large dog, navigates uneven terrain, and has been deployed in environments as varied as oil platforms and construction sites. At HMGMA, Spot's job is precision quality control. Fitted with an array of sensors and cameras, it circles each car body methodically, checking weld quality, panel alignment, and surface condition. What a human quality inspector might miss after a long shift. A subtle surface imperfection, a weld bead that ran 2 millimeters wide, Spot catches every time, on every body, without fatigue. The cars that pass body shop inspection move next to paint. At most vehicle plants, this is a long, slow process. The paint shop at HMGMA feeds into general assembly via a conveyor path that runs approximately 3,050 feet, just over half a mile. Multiple stages of coating, primer, base coat, clear coat, each one requiring precise temperature control and cure time. The facility's paint process is designed to handle multiple vehicle variants simultaneously, which becomes relevant when you understand just how many different powertrains this factory is capable of producing. But we will get to that. What comes after paint is the step that defines everything genuinely new about this factory: the integration of the high-voltage battery pack. For an electric vehicle, this is not a step in the assembly process. It is the assembly process. Every decision about how the car is built, the sequence of assembly, the design of the chassis, the routing of the cables and coolant hoses, radiates outward from this moment. Get it wrong, and you do not have a car. You have an expensive collection of parts. The battery packs assembled at HMGMA come from a facility right on the campus. HLGA Battery Company, a joint venture between Hyundai and LG Energy Solution, representing a $4.3 billion investment in its own right. Battery modules are assembled there and fed directly into the Metaplant's final assembly sequence, which means there is no truck journey, no logistics chain between battery production and vehicle integration. The two facilities operate as a single, vertically integrated system. The battery arrives, it meets the car. They become one. During battery integration, technicians and robots work through one of the most intricate choreographies in manufacturing. High-voltage cables routed with exacting care. A misrouted cable in an EV battery system is not a warranty claim. It is a fire risk. Coolant hoses connecting the thermal management system, which keeps the battery operating within its optimal temperature window. The mounting hardware torqued to specification down to the decimal, because a battery pack at highway speed is subject to vibration loads that would tear apart anything less than precisely assembled. The entire sequence is monitored by overhead camera systems and torque sensing tools that log every fastener, every connection, every parameter, a full digital record of exactly how each individual vehicle was built, car by car, vehicle identification number by vehicle identification number. Now, general assembly. And this is where 111 years of automotive manufacturing convention gets abandoned. Henry Ford's 1913 moving assembly line worked on a single principle. The car moves, the workers stay put. You stand at your station. The partially assembled vehicle comes to you on a conveyor. You perform your task, and it moves on. For over a century, every major auto plant on Earth has operated on some variation of that principle. It became as fundamental to manufacturing as the printing press was to publishing. HMGMA does not use it, not across General Assembly. Instead, the plant runs on cell-based assembly, a model in which the car stops moving and the tools and robots come to it. Each vehicle sits at an assembly cell, a designated zone, where a defined set of operations are performed before the car moves to the next cell on its own, carried by an autonomous guided vehicle, an AGV, operating on the factory floor. The AGVs at HMGMA are not the rudimentary magnetic strip-following carts that were called AGVs 20 years ago. These are intelligent mobile platforms, guided by the plant's dedicated private 5G network and onboard sensors, capable of navigating around each other, around human workers, around unexpected obstacles, without stopping the production flow. Over 200 autonomous mobile robots operate across the factory floor at any given time. The 5G network they run on was built in partnership with Samsung Electronics and uses a patented dual 5G and Wi-Fi solution developed specifically for this facility that has recorded zero communication-related downtime since deployment. Think about that for a moment. Zero downtime attributable to the network. In a facility the size of 275 football fields with over 200 robots moving continuously, the communication layer has not dropped once. That is not luck. That is architecture. Cell-based assembly does something the moving line model has never been able to do. It lets each cell be reconfigured independently. Add a step, remove one, change the sequence. At a traditional conveyor plant, changing the assembly sequence means physically re-engineering a significant section of the line. Weeks of downtime, hundreds of thousands of dollars in lost production. At HMGMA, reconfiguring a cell happens in the management software. The plant's entire production logic is defined digitally, and it can be rewritten. Hyundai calls the concept the software-defined factory. Approximately 60% of the innovations powering HMGMA were first developed and tested at the Hyundai Motor Group Innovation Center, Singapore, HMGICs, the company's advanced manufacturing research facility. Singapore was where the cell-based model was proven at scale, where the digital factory management systems were stress-tested, where the hard lessons were learned before being applied to a 16 million square foot facility in Georgia. The software-defined factory philosophy means the Metaplant can currently run 10 different powertrain variants with minimal retooling. Not 10 variants of the same powertrain, 10 fundamentally different configurations, different battery systems, different motor arrangements, different vehicle architectures, pushed out as software updates to the factory's operating system, in essentially the same way a Tesla pushes a software update to a car. The building itself reinforces this philosophy. The natural skylights throughout General Assembly are not an aesthetic choice. They are a deliberate quality decision. Natural light reveals panel gaps and surface imperfections that fluorescent lighting masks. Workers in the assembly area describe the environment as closer to an operating room than a factory floor. No raised voices. Normal conversation at normal volume. No vibration through the soles of your boots. Sound generated by the assembly process is channeled underground, acoustically routed through the building structure, the same way the stamping area manages press noise. And what remains on the assembly floor is, by any industrial standard, silence. Now meet the newest resident of the HMGMA warehouse. In January 2026, Boston Dynamics deployed the electric version of Atlas, the fully humanoid robot, standing upright, walking on two legs, hands capable of grasping and manipulating objects, to active industrial duty at HMGMA. By every publicly available account, it is the first deployment of a bipedal humanoid robot to sustained, production-critical work in an American manufacturing facility. Atlas's job at HMGMA is part sequencing and heavy lifting in the warehouse, taking components from storage, organizing them in the correct sequence for the assembly cells, moving loads that would cause repetitive strain injury for a human worker doing the same task across an 8-hour shift, then a 16-hour shift, then a week, then a year. Atlas does not get a repetitive strain injury, no bad back, no sick days. Before Atlas ever touched the real warehouse floor, it spent weeks operating inside the Robot Metaplant Application Center, the RMAC, a dedicated facility where robots are trained using a complete digital twin of the Metaplant, a virtual copy of the factory, running in simulation, accurate enough that a robot trained inside it carries its learned behaviors directly into the physical building with minimal recalibration. The digital twin is not just a training tool. It runs continuously in parallel with the real factory, letting engineers model proposed changes, test new configurations, and predict production outcomes before a single physical adjustment is made. The simulation runs ahead. The factory follows. Atlas also receives over-the-air software updates, OTA pushes of new skills, new movement routines, new task capabilities, in precisely the same way a connected car receives firmware updates. A new grip pattern for an awkward component. A revised routing path through the warehouse when the layout shifts, pushed remotely, applied overnight. Atlas wakes up knowing something it did not know the day before. The vehicles HMGMA produces right now are the Hyundai Ioniq 5, the first model off the line in October 2024, and the car that effectively announced to the American market that Hyundai was serious about domestic EV production, and the Ioniq 9, a three-row electric SUV that entered production in March 2025. A Kia model is scheduled to enter production in 2026, using the same facility and the same production cells, adjusted through software, not rebuilt, adjusted. Every vehicle leaving HMGMA goes through an EV-specific testing sequence that did not exist in car factories 5 years ago. Software flashing happens at the assembly line, OTA-style updates applied before the vehicle ships, ensuring every car leaves with the latest firmware. Automated uncrewed quality checks are performed by parking robots that systematically inspect the finished vehicle. Exterior panels, panel gaps, lighting systems, sensor calibration, producing a full digital quality report attached to that vehicle's production record permanently. The car does not leave the building until it passes. Nothing in that inspection sequence requires a human being to walk around the car with a clipboard. Once a vehicle clears inspection, approximately 70% of all HMGMA production ships by rail, an unusually high figure for an American auto plant, where most facilities rely primarily on truck transport. The connection is the Georgia Central Railway, which runs directly from the campus. The geography that made Bryan County an unlikely choice for a mega factory, rural, flat, close to Savannah's port, turns out to be precisely what makes the logistics work. The workers who operate this facility, the 3,200 Metapros currently on site, growing toward 8,500, are trained at a purpose-built facility in Bryan County, 89,000 square feet, capable of training 824 workers simultaneously, designed specifically for EV manufacturing and operating as Georgia's first dedicated training center of its kind. Workers are not handed a manual and pointed at a robot arm. They train on simulated systems, on physical mock-ups, and inside digital environments that mirror exactly what they will encounter on the floor. The training center was designed alongside the factory, not as an afterthought. The facility itself runs on fully electric power. No combustion machinery anywhere on the campus. Not in the press room. Not in the logistics bays. Not in maintenance. The building that manufactures electric vehicles is itself electrically powered. A design choice that is both environmentally consistent and operationally significant because an all-electric facility has fewer moving parts, simpler maintenance, and a mechanical profile that is far easier to manage on a predictive maintenance schedule, where the factory's software flags potential failures before they become breakdowns. Let's hold for a moment and look at the scale of what has been assembled here. Not just the building, but the entire ecosystem. A $7.59 billion factory, a $4.3 billion battery plant, 17 direct suppliers with a combined $2.7 billion investment, a purpose-built training center, a private 5G network, a digital twin running in parallel with the real facility, humanoid robots receiving overnight software updates, a quadruped robot conducting weld inspections, zero communication downtime, zero door gap tolerances out of spec, a workforce that works in silence, in natural light, without hearing protection. Total economic footprint, $12.6 billion, on land that was farming fields in 2022. The speed of that construction is worth returning to, because it is easy to let a figure like 24 months pass without registering what it actually means. The average new American auto plant, when one was actually being built, which had not happened at this scale in years, took 4 to 5 years from groundbreaking to first vehicle. HMGMA did it in half that time. The engineers who worked the construction schedule have described a project where at peak, multiple major construction phases were running simultaneously across different sections of the building, roofing one area while another area was already receiving production equipment, while another was being tested, while workers were being trained in a building that had not yet been fully assembled around them. The phrase that comes up repeatedly from people who were there is that it felt less like building a factory and more like conducting an orchestra, every instrument playing at once, never quite arriving at a moment of silence. And the reason that pace matters now, in 2026, is that the competitive pressure on American EV manufacturing has never been sharper. Chinese manufacturers are producing electric vehicles at a cost that Western producers are still working to match. The Inflation Reduction Act created financial incentives for domestic EV production that expire or reshape on political timelines nobody fully controls. Tariff structures on imported vehicles are shifting. The pressure to produce EVs at scale, in America, at a price point that works for American buyers, is enormous. And HMGMA is Hyundai's answer to all of that at once. The 500,000 vehicles per year capacity at full ramp is not a vanity figure. At that production level, HMGMA alone would account for a meaningful fraction of total U.S. EV production. Combined with existing Hyundai and Kia production and the pipeline of models entering production through 2026 and 2027, the group's American manufacturing footprint is being built deliberately, at a pace, and with a technological foundation that most established American automakers are only beginning to approach in their own facilities. Here is what most people overlook when they read about this plant. Every decision in the design of HMG, the cell-based assembly model, the software-defined factory architecture, the digital twin, the investment in robotics and AI-assisted quality control, the fully electric infrastructure, points to one conviction. The factory of the future does not look like the factories of the past, and the company that builds it first wins. They built it first, in Bryan County, Georgia, on farmland, in 24 months. And here is the question that nobody at HMGMA can answer definitively, because nobody fully knows the answer yet. If Atlas, the humanoid robot now walking the warehouse floor, keeps improving at the rate it has been improving, keeps receiving those overnight software updates, keeps learning new tasks, and the cost of deploying one keeps falling the way the cost of deploying every previous generation of industrial robot has eventually fallen, how many of those 8,500 jobs targeted for 2031 actually need to be done by a human being? That is not a rhetorical attack on the facility or the investment. It is the central industrial question of this decade. Because HMGMA is not just a car factory, it is a live experiment in what manufacturing looks like when you remove every artificial constraint on what a robot can do and ask honestly, where does the human being fit? So I want to know what you think. Drop it in the comments. 10 years from now, do humanoid robots like Atlas replace the majority of factory assembly workers? Or do humans remain irreplaceable on the floor in ways that a robot, however capable, simply cannot replicate? I am genuinely curious where you land on that. If this story hit differently than you expected, if you came in thinking this was about a car factory, and you are leaving thinking about the future of work, share it with someone who needs to see it. Hit the like button if you want more content like this. Make sure you are subscribed, because the next video goes inside a facility that makes HMGMA look like a warm-up act. We are looking at the most automated port in the Western Hemisphere, and the numbers involved are going to stop you cold. The first Ioniq 5 built at HMGMA rolled off the line on a Tuesday afternoon in October 2024. It passed through a body shop that no longer needed human hands to guarantee a perfect door gap. It passed through a paint shop where every coat was applied by machine. Its battery was assembled a few hundred feet away and walked to the line. It was inspected by a robot that walks like a dog. And it left the building on a rail car, headed for a customer who probably has no idea how it was made. Now you do.